7th graders, this is Mrs. Myers with a review of our Unit 1 study guide. So you should have a completed study guide in front of you, and right now what I'm going to do is I'm going to go through the answers and make sure that you make corrections and you understand why you missed a particular question. Bring your study guide back to class tomorrow, as it is due tomorrow before the test. Let's go ahead and get started. So first we're talking about perfect squares. A perfect square is a number with an integer. A whole number is its square root. In class, we learned about how to create them. So we have different perfect squares here that are shown. And we also memorized them. So if we move down here, we're going to circle all of our perfect squares. So the first question, circling all the perfect squares, 361 is a perfect square because 19 squared is 361. 0 is a perfect square because 0 squared is equal to 0. 336 is a perfect square because 6 squared is equal to 36. On our second row, 400 is a perfect square because 20 squared is 400. And then our last row we have 2. 225 is a perfect square because 15 squared is equal to 225. And then our last perfect square in this list is 1 because 1 squared is equal to 1. Let's look at the next question. Circle the 3 true statements. So that's important. We're looking for true statements and we know that there are 3 of them. So we have the square root of 10 is equal to 100. This would not be true because the square root of 10 is not 100. The square root of 100 is 10. Okay, so with our perfect squares, you should see the larger number. So if this were true, it would be the square root of 100 is equal to 10. Inside the square root sign is your perfect square, and then the actual side length is going to be the smaller number. So the second number, 7 is equal to the square root of 14. That's not true. 7 is equal to the square root of 49. The third one, the square root of 324 is equal to 18. That is true because 18 squared is 324. And then 14 is equal to the square root of 196. That is also true. Let's look at this next one. The square root of 3 is 9. So let's think about that. If we wrote that, we would say the square root of 3 is equal to 9. All right, that's not true. The square root of 3 is not 9. The square root of 9 is 3. And then the next one, the square root of 225. Square root of 225 is equal to 15. And over here we had that one. So that one is also going to be true. So we have 3 correct answers listed. Okay, now we're going to look at looking at equations that best describe a model. So if we look at the model, we see our side lengths. We have a side length of 5, a side length of 5. So this is showing the square root of 25. So the area here would be 25 and our side lengths are 5. So let's go ahead and see our choices. This is saying 25 is equal to the square root of 5. Okay, 25 is your perfect square. 5 is your side length. So this one is going to be wrong. 5 is equal to square root of 10. That doesn't match our model. 5 squared is equal to 25. So let's think what that's saying. 5 squared, which is 5 times 5, is equal to 25. So that one is true. And then this last one is wrong because it says 5 squared is equal to the square root of 25. The square root of 25 is 5, not 5 squared. Okay, and you guys really need to be studying those perfect squares. Look at your notes and be studying to make sure that you can identify perfect squares tomorrow. Our brain dump up here. So you guys can be practicing that tonight. Before the test, you're going to write down all of your perfect squares from 0 to 400. Let's go on to the next section. So this section is absolute value, and we learned that absolute value is the distance a number is from 0 on a number line. Please make sure that you're drawing number lines when you need to. If you're unsure of the distance a number is from 0, you can draw a number line. And also remember, absolute values are always positive values. So distance is always given as a positive value. You can use your Desmos on these questions. So we have an absolute value key, so you can do that, or you can just take what you know about absolute value being positive to solve these problems. So again, we're looking at problems that are true. We're looking just for the true statements. So for this, this is saying 8/9 is the absolute value of negative 8/9. So in other words, is 8/9 or 8/9 the distance negative 8/9 is from 0, and that would be true. Fractions have absolute value just like whole numbers. The next one, the absolute value of 22 is equal to 22. Again, it's positive, it's the absolute value, it's the distance a number is from 0. Another example we have here is the absolute value of 54 hundredths is equal to 54 hundredths. That's true. Decimals can have absolute value, that's their distance from 0, and it's always going to be a positive amount. But let's take a look at this last one. This last one is saying that negative 6 is equal to the absolute value of negative 6. This one is going to be false because the absolute value of negative 6 would actually be 6. So to make this true, it would be 6 is equal to the absolute value of negative 6. And again, we talked about it in class. If this confuses you, you can rewrite the equation with your absolute value sign on the left to say that the absolute value of negative 6, put it in your calculator, or just think about it, and you'll know that that should be a positive 6. Let's look at our next question. This is one that tripped us up on our skills check a few weeks ago. We're plotting 2 points that x could be when 3 is equal to the absolute value of x. So that may seem a little confusing at first because we are using algebraic variables, and this is an algebraic equation, to figure out which 2 points I should plot. But I know that absolute value is always positive, and I'm looking for which 2 numbers, okay? So 3 is equal to the absolute value of which 2 numbers? So which 2 numbers could I put in between the absolute value bars? Well, I know that 3 is equal to the absolute value of positive 3, and 3 is also equal to the absolute value of negative 3. Because again, it's a positive value and it's the distance from 0. So x could either be positive 3 or negative 3, because either way, the absolute values are going to be the distance from 0, 1, 2, 3, or over here, your distance is 3 for either number. At any time, you need to pause the video and look at your answers again, or even go back and listen to it again. Please feel free to do that. Okay, now we're going to look at powers of 10. So powers of 10, you should fill in your chart. You should have filled this in. You could do that from your notes or just from your memory. And remember, when we have negative exponents, so we have negative exponents here, negative exponents are not negative. So negative exponents does not mean negative numbers. They're actually decimals because we're dividing by 10 instead of multiplying by 10, like with positive exponents. So 10 to the negative first power is equal to 1 over 10 to the first. So you're dividing by 10 one time, so you're putting that on the bottom. And that means your 1/10 times 1, which is 1/10, and then our decimal would be 0.1, 1/10. You can also use your decimals. You can put this into decimals to get your decimal, or we learned in class we could put it in our decimal to check to see if it's the correct power of 10. So following this pattern, 10 to the negative second is going to be 1 over 10 to the second, which is 1/10 times 1/10, which simplifies to 1/100th, which is 0.01. 10 to the negative third, we're not multiplying by 10 to the positive third, right? So if we had 10 to the positive third, it would be 1,000. But this is 10 to the negative third. So instead of multiplying by 10 3 times, we're dividing by 10 3 times. So this is 1 over 10 to the third, which is 1/10 times 1/10 times 1/10, which is 1 over 1,000, which as a decimal is 0/10ths, hundredths, thousandths, 1,000. 10 to the negative 4 is going to be 1 over 10 to the fourth, which our standard form would be 1/10. We're dividing by 10 4 times, which is 1 over 10,000. And then we have our decimal there. That's tenths, hundredths, thousandths, 10,000ths. Again, there are no negatives here. There are no negative numbers. There are only positive numbers that are decimals that are less than 1. The other thing I want to note is that the numbers in the decimal are never going to be 3 or 2 or the exponent. They're not going to represent the exponent. They're going to represent the power of 10. So you always have a 1 here. Okay? And if we jump down here, we can look at the Desmos tip. The Desmos alert, you can check if things are equivalent quickly by using your Desmos. So if I'm trying to figure out what 10 to the negative 4th is equal to, I can put in 10 to the negative 4th, and if I put that, it'll give me this value. If I put 1 over 10 to the 4th to see what that's equal to, it'll give me the power of 10. If I have expanded form and I put this in my Desmos calculator, 1/10 times 1/10 times 1/10 times 1/10, it'll give me 10 to the negative 4th. Same thing over here. If I put in 10 to the negative 3rd on my Desmos, it's going to give me the decimal. If I put it in as 1 over 10 to the 3rd, because I know that's the equivalency, it'll also give me the decimal, as well as our expanded form. So you could be practicing. You can go look at a Desmos calculator, an app on your phone or on the computer, and you can practice some of these using Desmos, because you will have access to your calculator tomorrow during the test. So let's look at some more powers of 10. So we're looking for all numbers that are equivalent to 10 to the negative 5. So before I even look at my choices, I'm going to think about, I could put it into my Desmos, right? We could put that into our Desmos. And so you notice I have my Desmos calculator here. So just like the example that I gave you, you can put in 10. And you can use your exponent here and put into the negative 5 power. And it'll give you just 1 times 10 to the negative 5. So if we have it that way, we can multiply that times 1, and it'll still give us that. So what's going to happen is if you have those numbers that are bigger, it's a little bit harder to do with Desmos using the exponent, but you can go the reverse direction. So what I can do is I can put in one of these choices. So I'm going to put in 1 over 100,000 into my Desmos calculator. So I'm going to put in 1 divided by this right here, 100. Okay, and you notice if I put in 1 over 100,000, this right here, it gives me 10 to the negative 5. Okay, so it matches, so I'm going to circle this as a choice. So again, when you put in 10 to the negative 5th, it may not give you the fraction, but if you put in the fraction, it'll give you whether it's 10 to the negative 5th. Okay, and then just like we talked about before, this can't be right. 1 over 500 can't be right. 1 over 500,000 can't be right if 1 over 100,000 is right. But if I do, again, we can try it right on our Desmos. I'm going to pull that up again. I'm going to put 1 over 10 to the 5th in my Desmos calculator. So I'm going to put 1 over 10 to the 5th power, and look what I get. When I put that in, it says it's the same as 1 times 10 to the negative 5th. So this is going to be true, and that's how you can use your Desmos calculator. And then, of course, we can put this one in. I can go ahead and put, let's try that. Let's see if that works. 0.00001 times 1. And it gives us 10 to the 5th. If I put the decimal in, it gives me 10 to the negative 5th. So I just put this decimal in. The 0 is not showing up, the one that is before the decimal, but if you look, I have 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros there, and it gives me the correct answer. So I can go back over here, and I know that this one is correct, and this one is correct. Let's take a look at the next one. This is a perfect example of when I can use my Desmos calculator again. I'm just going to put in the decimal. Move this over here. I'm going to put in my decimal 0.0001. Okay. Let me clear it. 0.001. I can go ahead and put it in as it is there. Oops, I forgot one of my zeros. 0.3 zeros. 1, 2, 3, 1. All right, and what I'm going to do to get the power of 10 is I'm going to multiply that times 1. Check it out. When you multiply it times 1, it actually gives you the power of 10. So it gives us that it's 10 to the negative 4th value. So this is what we're looking for. We're looking for the value of the exponent just from there. So I'm going to put that here because this is equal to 10 to the negative 4th. Okay. Again, we have another example. We have, we're looking for the power of 10 that's equivalent to 1/10 times 1/10 times 1/10. We could do this from memory, what we remember. We could go ahead and simplify it and multiply 1 over 10 3 times. And this is 1 over 1,000. Okay. And we might know how to write 1,000th as a decimal and then change it to a power of 10. But let's use our Desmos. So I'm going to show you how you can do that. You can take your calculator, and I'm going to put in the fractions that are given. I'm going to take my fractions. I'm going to take 1/10 times 1/10 times 1. Oops. Let me try that again. 1/10. Okay, and when you get that, you're going to notice you get this decimal, right? So let's try to see if we can just multiply it by 1. Okay, so if I multiply it by 1, it's not going to give me the power of 10, but it will give me this number. So what you can do is either write that one down, because I need the power of 10, or I can just go to the next line. And when I go to the next line, if I want to bring this down, I can retype it, or I can just press answer. Okay, so now I've got the decimal form, but it wants the power of 10. So I'm going to multiply this times 1. It's not giving it to me that way. So let's try something else. Let's try to clear this, and I'm going to put in 0.001 times 1. It won't give me the power of 10 that way. So let's do some checking to get the power of 10 from the decimal. So let's do 10 to the negative 3rd. Okay? So if I do 10 to the negative 3rd, I get the same decimal that I just had. So that's a way you can use Desmos to check. So this would be 10 to the negative 3rd power. So I'm going to write that in the box. 10 to the negative 3rd. All right, we're going to look at one answer that's true. So I'm going to see if 0.01 is equal to 10 to the negative 1. That is false. I know that's false because 10 to the negative 1, I could put it in my Desmos. If I put in 10 to the negative 1, I'm going to see what I get. Clear. 10 to the negative 1. Okay, I get 0.1. Okay, and you can see that that's not the answer. That's 0.01. And then if I put in this one, that's a negative. So I can go ahead and delete that one. I know that one's not going to work. This one has a 4 in it, and that's never going to be the answer. When you have powers of 10, you're only going to have 10s or 1s. So let's check this one here. Let's see if this one's right. So again, I'm going to pull up my Desmos calculator, and I'm going to put in 10 to the negative 2 and see what decimal I get. And that's it. So that must be the correct answer. So pretty much most of these, your Desmos is going to be a handy tool, but you're going to be able to eliminate things just from what we learned in class. Like negative exponents are not negative, and negative exponents should not have numbers when we're dealing with powers of 10 that are 4s, non-1 numbers. Okay, let's keep going. Now we're going to compare in an order, not using a calculator. One of the things that's really important for this is that you guys know your vocabulary. So we've been stressing this a lot in class. Ascending means smallest to biggest or least to greatest. And descending, we're going down. That means biggest to smallest or greatest to least. Now, one of the other things you can do is you can use benchmark fractions to estimate fractions that you don't know. So you can think about a fraction and try to determine whether it's closer to 0, 1/2, or 1 whole, or sometimes you can see if it's closer to maybe 1/4 or 3/4. So these are some strategies that we talked about in class that can help us compare and order numbers. So let's look at our checklist here. we have an example. Our checklist to solve, are you going smallest to biggest or biggest to smallest? Or are you going least to greatest or greatest to least? Next, you're going to look to see if you can go ahead and identify the smallest or biggest number, because that's going to help you when you're looking at a list of numbers figure out which can be eliminated. Which brings us to our next one. Can you eliminate any choices based on the biggest or smallest number? And then from there, can you do some estimating with the fraction? And then, of course, if you need to, draw a number line, especially when you're dealing with those negative numbers. Because remember, the negative numbers, the more negative a number is, or the farther away it is from 0, the smaller it's going to be. So, for example, if I'm comparing negative 8 to negative 1, okay, 8 is normally greater than 1, but negative 8 is less than 1. So with a fraction, if I have negative 1/2, and I'm comparing that to negative 1/4, okay, 1/2 is usually greater than 1/4, but because they're negative, negative 1/2 is actually going to be farther away from 0, so it's less than negative 1/4. So let's look at our list here. It says which is in descending order. So we're looking for descending order, which means descending, you're going down. So you're going to go from greatest to least. So we're looking to see, let's see if we can find in this list the biggest number. All right, so I'm just going to look at my first list here, and I'm going to see if I see the largest number. Anything that's greater than 1. See if you can find that. Oh, anything greater than 100% is greater than 1, and this is going to be the greatest because it's 125%, okay? If it's going greatest to least, this number here should come first. And if you look at C, C is the only choice that has 125% first. I know that that's the obvious choice at this point, but let's go through, we've done this. We've picked the biggest number. Let's see if we can pick the smallest number. That's right. Our smallest number is going to be the only negative we have here. And if you notice, we have our largest number at the beginning, our smallest number at the end, and then that's the only choice that makes sense. So we can conclude, just from using our number sense, that C is the correct answer. And notice we didn't have to change anything to a decimal. We just used our checklists. We looked to see the smallest to biggest. We picked the smallest to largest, and then we eliminated any choices. We didn't have to estimate the fraction here, and we didn't have to draw a number line, but we do know that all negative numbers are less than positive numbers. Let's go to the next example. Oops, I think we might have one here. Oh, no, next page. All right, so now we have another example. Write the numbers in order from greatest to least. So we're going to go ahead and highlight greatest to least. So we have that even written on the table. So you might see test questions like this where you click and drag. So when I'm going from greatest to least, so I'm going to think back to that checklist. And I'm going to look at my numbers and see if there are any that are obviously greater or less. Okay, now I don't see right away what's greater because I don't see anything that's greater than 1. All of these are going to be less than 1. But I do see one that's going to be the least because it's a negative number. So I'm going to plug in my negative 10 and 4/10 here. So I've already used that one. Okay, so now I'm going to look at what I have left. I have 51%, 1/2, and 1/9. Now between those two, I'm going to think of my benchmark fractions of 1/2. 51% is greater than 1/2. 1/2 obviously is 1/2, and then 1/9 is less than 1/2. Okay, so 1/2 is equal to 1/2. 51%, because 50% is 1/2, 51% is greater than 1/2. So we've got the order right here. We took our negative, so now the one that's greater than 1/2 is going to be first, 51%. Followed by the one that is 1/2, and then 1/9 is really close to 0. So that's going to be our order. Now sometimes we can change things to decimals if we need to, but for this particular one, we could just keep them in our regular form and think about our number sense, like what they're closest to. Let's take a look at the table below. Mr. Rivera gave a pretest to his earth science class. who has the lowest score. So again, let's go ahead and highlight lowest. And then we're going to take a look. We're looking for the least. So we have 5/10, we have 4/9, and we have 60%. So for this one, I'm going to take a look and I'm going to think about that benchmark of 1/2. Okay. So again, I know that 0.5 is equal to 1/2. So that means L had half of the questions correct. Okay. I'm going to take a look at this one. 4/9 is going to be less than 1/2 because I know half of 9 is 4.5, right? If I split 9 into 2 parts, each of them would be 4.5. So I know this one is less than 1/2. But I know that 60% is greater than 1/2, okay? Now, if I wanted to change 4/9 to a decimal, I could take 4 and divide it by 9. And I could do the long division. 9 goes into 9 goes into 40 4 times minus 36. I get 4. I keep bringing down my 0, so it's going to be 4. So this is actually going to be 0.4 repeating. Okay, that's going to be the decimal equivalency if I needed it. But look, guys, we really don't need it because I know that L was equal to 1/2. Parker's score was less than 1/2, and Alvin's score was greater than 1/2. So when I'm looking for the lowest score, the only one that's less than 1/2 is going to be Parker with 4/9. And I can confirm it with, our decimal over here, but it really wasn't necessary if I used my number sense skills. All right, let's look at the next question. This time, we're looking for all of the numbers that are less than 1. So let's think about what 1 means, okay? 1 whole is equal to, let's think about the percent that would be. That would be 100%. Okay, so that'll help us look for any percents. And then also, remember, anything that's less than 1 it can't be an improper fraction. So it's going to be a regular fraction. It can't be improper. Remember, improper, your larger number is on top. So let's take a look. 13%. Is 13% less than 1, which is 100%? It sure is. Okay. 1 and 1/100th. Okay, that can't be right because that's a little bit more than 1. That's not less than 1. 5/4, we have an improper fraction. 4/4 is equal to 1, right? And this is greater than 1, so that can't be it. Negative 4.5. Well, at first you might think 4.5 is bigger than 1. However, this is going to be less because all negatives are less than all positives. 100% is actually equal to 1, so we're going to have to cross that out because it says less than 1. 8/9 is 1/9 away from a whole, so that's definitely less than 1. 1.4 is greater than 1, so that can't be it. 9/4 is greater than 1. It's an improper fraction. We're going to cross that out. But 88% is correct because 88% is less than 100%, which is our percent form of 1 whole. All right. Now last part we're going to look at in the study guide is scientific notation, and this is a no calculator section. Now this is something we really need to focus on. I know my class particularly has had some trouble with moving the exponent to the right place. So when we have a number, the first thing we need to realize is that every whole number has a decimal point at the end. Even though you don't see a decimal point here, when you have to move it around, you need to recognize that it's at the end of the number. When we have positive exponents in scientific notation, that means you're going to move the decimal to the right, and it's reserved for really large numbers. When you have negative exponents, like this -1, it means you're going to move the decimal to the left. So you have smaller numbers that are less than 1, between 0 and 1, when you have your decimals. So let's talk about how we're going to do this back and forth between scientific notation and standard form. So the first example here, I have 7.03 times 10 to the -5th. It's a negative, so we're going to move to the left, Okay, the number is going to be smaller. The number is going to get smaller. We're going to take that coefficient and make it smaller. So 7.03 times 10 to the negative fifth, I'm going to move this 5 places. 1, 2, 3, 4, 5. Place my decimal and put in my zeros. And I can put one in before it as well. Now don't just leave it like that because the decimal is showing in 2 places here. So you're going to have to rewrite it. 0.1234703. So again, all I did was move my decimal 5 places to the left. All right, now I'm going to go from standard form to scientific notation. So you're going this way, it's already been moved. So I'm going to unmove it. So for scientific notation, it's going to be after a whole number, the first whole number in the problem, or anything between 1 and 9.9. So I'm going to have 5.0 times 10. Okay, this is a really small number, so it's going to be a negative exponent. And now I just count the number of places I move the decimal. So to get it back to where it was, I would move it 1, 2, 3, 4, 5 places. So this is going to be 5.0 times 10 to the negative fifth power. So be careful with that. If it's a really large number, it's going to be a positive exponent. If it's a small number, it's going to be a negative exponent. So now we're going to talk about how we compare and order numbers in scientific notation. So the first step you're going to have is you're going to determine whether you're, just like before with rational numbers, you're going to determine whether you're ordering smallest to greatest or greatest to smallest. The very first thing you do is compare the exponents. Use number lines if you're having trouble ordering the negative exponents. And then if two numbers have the same exponents, you're going to look at their bases, also called the coefficient. You don't have to change them to regular numbers, but you can if you want to. All right, so let's take a look at this. This is ascending, and I know that ascending is going to be least to greatest. Okay, least to greatest order. So again, I'm going to look first. If you look at, we determine whether we're ordering smallest to greatest or greatest to smallest, and we determine it's least to greatest. So now I'm going to compare the exponents. So I've got negative 3, negative 2, negative 11, and negative 2. So my smallest number is going to be the one that's the most negative. So it's right here. This one is actually going to be my smallest because it has an exponent of negative 11. None of the others are as small as that number. So that's going to be my first one. It's going to be 9 3/10 times 10 to the negative 11th power. Okay, so I've used that one. All right, now when I'm thinking about what's more negative, negative 3 is smaller, so I have that one's next. The other two are negative 2. So this is going to be my next one. 6 8/10 times 10 to the negative 3. Okay, so I'm going to use that one. And so now notice we have, I'm going to erase this a little bit, the two that we have left. So let's highlight those. The two that I have left are 4 times 10 to the negative 2 and 5.0 times 10 to the negative 2. They both have the same exponent of negative 2. So what we do if they have the same exponent is we compare their bases, or the first number. So if I look at these, I see that this has a 4, okay, and this has a 5.1. Those aren't negative numbers, remember, so don't think of them as negatives. We've already looked at the negative exponents. Just think about the numbers themselves. Ignore the exponent now that we've determined that they're the same power of 10. So what's greater, or what's going to be least? Because we're going from least to greatest. So the least number between these is going to be 4. So it's going to be 4 times 10 to the negative 2. Because 4 is smaller than 5 times 10 to the negative 2. So they have the same exponent, but 4 is less than 5. All right? So be careful of that when they have the same exponent. You're ordering the number by its base. Our next example, we're going to order from greatest to least. Greatest to least. So again, I'm going to look, we have the same numbers here, so we're going to look for the greater exponent. So greater is going to be the bigger number, what's worth the most. So we either have 1, we have -6. So these are all the same numbers, just in different order in each of the lists. So the greatest is actually going to be +1, okay? Because 1 comes before -5 and -6. So I can eliminate C and I can eliminate D, because they have the -6 coming first, and those numbers are actually going to be lesser value. So between these two, I'm going to just take a look. It goes from 1, -5, -6, -6. Okay, so does B. If I just look at the exponents, it's 1, -5, -6, -6. All right, well, I know the -5 is the same here, so now I'm just looking at these two. So remember, they have the same exponent, right? So when they have the same exponent, we're going to look at the base. And we're going from greatest to least. So we're going to have to figure out what's greater, 7.03 or 7.3, or excuse me, 7.3. If we're having trouble figuring that out, I can line them up, 7.03 and 7.3, and we can compare by place value. They both have a 7 in the ones place, but 7.3 has a 3 in the tenths place, where 7.03 is a 0. So this is actually going to be the larger number. So this number here is going to come before this one. So if you look below, we've got the correct order, 7.3, which is greater than 7.03. So our correct answer is going to be B. All right, that's it for our study guide review. I hope you've been able to look at your original selections and make any changes as needed. And I wish everybody the best of luck on their test tomorrow. Have a good night.